Lesson 2.2 is another property called the distributive property. And this one's my favorite because it actually is something that you may not know, and it's going to be really useful. So some vocabulary we need to know is equivalent numerical expression. It's numerical expressions that have the same value. So for example, 2 plus 7 is equal to 3 times 3. Both equal 9, even though they're different expressions. Then equivalent variable expression is very similar. So this is similar because equivalent variable expressions have the same value for all values of the variables. So for instance, in this case, 2x equals 5 plus x. So x on both sides has to equal 5 in order for this to be true, because 2 times 5 is 10, and 5 plus 5 is also 10. So let's just go through what exactly the distributive property is. So in algebraic terms, it's saying that A times B plus C is the same thing as A times B plus B times C. And the same goes, and it doesn't matter which side the A is on, but basically whatever's on the outside, you multiply by the terms on the inside. So here you can do B plus C, so it ends up being B times A plus C times A. And the same thing works with the subtraction. So A times B minus A times C. Here you need to be a little more careful because subtraction, you need to keep it in the right order. You can't say A times C minus A times B because it's B minus C. In terms of numbers, here's a few examples. So you could have 4 times 6 plus 3. So you could do it either way. You could add these up first and then multiply it by 4. Or you can say 4 times 6 plus 4 times 3. You're going to get the same answer. And then here, 5 times 7 minus 5 times 2. So this is the distributive property. It's taking, when you have parentheses, and distributing what's on the outside to the inside. So we're distributing this A to both terms on the inside. So let's kind of go over the two methods that you can use to solve a problem using the distributive property. So you're raising money for a field trip. The school matches your earnings. So whatever you make, they're going to give you that same amount too. So they're like doubling it. So you earn $125 selling sandwiches and $95 at a car wash. Find the total amount you have put towards your field trip, including the school's contribution. So remember, the school matches your earnings. So method 1 is find the amount you earned total from both the sandwiches and the car wash. Then multiply the result by 2 because your earnings are matched by the school. So in this case, you could write it as 2 times 125 plus 95. We complete what's in the parentheses. So 2 times 220, we earned 440. That's the first method. So you kind of did what was in the parentheses first, then you multiplied the outside. Using the distributive method, find the amount earned and matched for selling sandwiches, then find the amount earned and matched for washing cars, and then add the amounts together. So we could say 2 times 125 plus 2 times 95. We just use the distributive property up above. So 250 plus 190, we also get $440. So here's a problem for you to try at home. You and a friend spend $5 on a movie ticket and $4 on snacks. You each spend that. Write and evaluate 2 expressions that can be used to find the amount you both spent. So set it up as if you're solving it using method 1 and method 2 and bring it with you to class. So press pause now and try it. So one of the benefits of the distributive property is it really can help you with mental math. So for example, here's a problem that may be more difficult to do if you didn't use the distributive property. So you buy 5 shorts for $15.02 each. Use the distributive property and mental math to find the total cost of the 2 shorts. So we have $5 times $15.02. instead of multiplying 5 by 1502, because say we don't have a calculator, what we can do is say 5 times 15 plus 0.02. Same thing. And then we can use the distributive property to say 5 times 15 plus 5 times 2 cents. Get those values separately, so 75 and 10 cents, and then add them together. So the total cost for the shorts is $75.10. That's a good way to do this using mental math for something that would have been much more difficult if you hadn't used the distributive property. So here's a few to try at home. I want you to do it with mental math. I know I let you use calculators in school, but it's good to be able to do these without a calculator. So figure out if you need to break it into 2 components or 3, that's fine, but you should be able to do these using mental math. So press pause now and try them out. So the last part is writing equivalent variable expressions. So this first example, the first thing we're going to do is use the distributive property. So 15 times 3y minus 15 times 4. And then we can actually multiply the 15 by both of those terms. So what we end up with is 45y minus 60. That's as simplified as we can get because we don't know what y is, so we don't have something to plug in for y, and the 60 doesn't have a y associated with it, so we can't subtract or add it together. Another example is, what if you have a negative number on the outside? When you distribute it in, you want to say negative 6 times 3x minus, keep that minus there, negative 6 times 1. Then multiply, get our 18x, negative 18x minus negative 6. And remember, when it's minus, so 2 minuses together, or minus negative, it's like a double negative, so it becomes a positive. So negative 18x plus 6. And lastly, here, we're multiplying by a negative again. Don't let it trip you up because it's on the other side. It doesn't matter. It still needs to be distributed to what's on the inside. So 2z times negative 11 plus 5 times negative 11. So we get negative 22z plus negative 55. And then we don't need to say plus a negative number. We can just say it's minus 55. So use those to guide you, but use the distributive property to write equivalent variable expressions for the following 3 problems. Be careful to watch your signs. So if there's a negative on the outside, you still need to bring it in, and also make sure you keep these minus signs. So press pause now and give it a try. And lastly, we can use the distributive property to help us find areas of geometric figures. So here, we want to find the area of the rectangular triangle. Let's start with a rectangle, which is a little easier. The formula for a rectangle is just length times width. So our length times width, or length times width, either way, doesn't matter, but the 2 sides you want to multiply together. So in this case, let's substitute first. The length is 3x minus 8 times 2. So now we can use this and distribute it to the inside. So 2 times 3x minus 2 times 8, or 8 minus 2, which when you multiply it ends up being 6x minus 16. Because they didn't give us any units, we can just say square units or units squared. Either one would be appropriate. But we put brackets around the 6x minus 16, so you know that the unit is for the whole term, not just for the 16. So now we have this triangle, and we need to know the base and the height. The base is here, and the height is here, and they're labeled. So the height always makes a 90-degree angle with the base and then goes to a point. So 1/2 base times height. So let's plug in the base and the height. So our base is 16. Our height is 2y plus 1. To make it easy, we can just get rid of this 1/2 by multiplying it by 16. So 8 times 2y plus 1. Use the distributive property. So 8 times 2y plus 8 times 1. and then we can simplify it by multiplying, so 16y plus 8, and again it's square units because it's areas. That concludes, oh, no, it doesn't conclude. I have two more problems for you to try and bring tomorrow. So use what we just did on the previous slide to help you solve these two area problems using the distributive property.